in speed governors for the control of engines, of machinery. The principle is exactly the same, and it's illustrated by this little model we have here. Let me tell you what it's made up of. It's made up of a couple of flyweights on the linkage, mounted on a shaft which can be driven about a vertical axis. And we suppose that, there's an engine driving it. In fact, there's a small electric motor underneath, which I can switch on and will in a minute. And that will drive this around at a certain speed. Now, the idea is that if this is a large mechanical machine, for example, and if for some reason the load should change, we would like to keep the speed constant. That's maybe very important. And this is a device that will do just that. So if I turn the electric motor on, you can see it's driving around. The links come out. And in doing that, they move another link here which controls the fuel supply. In this case, it's the electric voltage. And that means that if the speed, for some reason, changing load perhaps, should change, suppose the speed goes down, then the flyweights will go down. This linkage will operate a valve and will increase the fuel supply, and so the speed will go up again. So the basis of that provides what's called speed governing and is widely used on large machinery. This sets the speed, so I can turn it up or turn it down according to that control. It's an application that's been used for many years, first in windmills and then by James Watt, perhaps the best known of all, to control the speed of his steam engines. Another experiment with circular motion is to make the plane of the circle vertical. And we'll do a few experiments on that. The first one is